Algebra 1 students, lesson 73. Are you ready? There are two parts to this, and they're both kind of fun and easy. I mean, I'm a little biased. I think this is really entertaining. I know you might not. The first part is called factoring a special kind of expression that's called the difference of two squares. I think we've talked about the difference of two squares before, but I'm going to review and explain it all as if you didn't know. Difference of two squares is an expression that might look like this. There's a square and a square. They might have numbers in front of them. They might have more complicated exponential arrangements, but you can recognize that both of them are perfect squares in some way. When we get into the examples, I'll show you more complicated versions of these. But they are joined by a subtraction sign. There's the difference, two squares, there are the two squares. When we see something like this, all we have to do is recognize it, and we can immediately factor it into x minus y, x plus y. We can factor it into these two binomials. And then if you want to just prove to yourself that it works, we can multiply x squared minus xy plus xy minus y squared. Oh, I forgot to write the square there. X squared cancel minus y squared. So that will take us back. So we can multiply these to prove that it works, but when we're working this way, we really don't have to do any work. As soon as we realize that our expression fits this pattern, we can just write it out. And notice that these binomials can be in either order. I could put x plus y, x minus y. That doesn't matter as long as you have the differing signs. Okay, so this is the difference of two squares. All we have to do is recognize it. Example 73.1. John throws us a curveball. We look at this and we go, oh wait, there's a square, and 4 is a square, but they don't have a minus sign in between them. And then we hear John giggling in the background, and we go, okay, I get it, right? X squared minus 4. Now we have the pattern of x squared minus y squared, right? We have two squares. So what we can do is identify the square root of each one, right? It would be x and 2. So we have x minus 2 and x plus 2. That's our final answer. Make sense? It's so easy. Let's try another one. My paper is so thick I can't separate it. Okay, example 73.2. Factor 49 m squared minus a squared. Okay, this is what I was talking about where we get numbers in here and it's a little more confusing. And sometimes it helps to write the root of each side over to the edge so that you know what's going on. 49 is a perfect square. The root of that is 7. M squared is a perfect square. The root of that is m. And then a is a perfect square. The root of that is a. So I'm writing those over to the side, and now I can create my binomials. This time I'm going to put the plus sign first. It doesn't matter which order the signs are written in the binomial as long as you get a plus and a minus. There's the right answer. Now it's going to get trickier because you know John, he likes our brains to grow. Minus 36 a squared plus 25 y squared. Again, sirens go off. I notice the perfect square numbers, but I need to see that minus sign in between. And then I realize, oh, he's playing a game. So I switch the order. Notice I don't just put the minus sign into the middle. I have to rearrange the chunks so that that stays, the minus sign stays in front of the 36. Now I'm going to write my roots over here. This would be 5y, and this would be 6a. So now, 5y plus 6a, 5y minus 6a. Cool, right? There's one more. Example 73.4. Factor. Now you don't have to copy it out of the book wrong like me, but I just want you to see exactly where we're starting from. Okay, we have the same problem as last time. The first term has a minus sign, and there's a plus sign in the middle. So we rearrange. This needs to come first. 49a squared minus 36 x to the 6 y to the 4th. Okay, these exponents are crazy, but we'll deal with them. Let's start with this one. 49, the square root of that is 7. A squared, that would be just a plain A. Now over here, the number is easy. 36 has a root of 6. What's the square root of x to the 6? Well, we have to take those exponents and break them in half, right? If this is x to the third, then when we multiply it by another x to the third, we would add the exponents. 3 plus 3 will give us 6. So we can find the root by simply dividing the exponent in half. And then same things with the y's. We find the root by dividing the exponent in half, and it would be 2. So now we get 7a minus 6x third y to the second. And this time I put the minus sign plus and the positive second. Doesn't matter. 6x cubed y squared. The end. Happiness. That's the right answer. Okay, so I'll just write it again. This time I'm going to write it with this format because a lot of times for rules and formulas, we use A's and B's rather than X's and Y's. It's just sort of a tradition. A plus B, A minus B. This is the puffy cloud of knowledge. And it's called the difference of two squares theorem. Oh, you guys, my marker has officially died. It's raspberry. Can you see? It's raspberry right there. But it is no more. So I'm going to have to switch colors on you for the next lesson. Or no, for the next part. That was part A, difference of two squares. Right? Part B. What color are we going to now? This is... What the heck is that even called? Some kind of rose. Is it primrose? Maybe. Can't read the writing. Part B of lesson 73 is probability without replacement. So games theory again. Remember we did the flipping of the coins and the spinning of the spinners. This time we're going back to our urns. Remember the urns? Well, you've got an urn, and it's got marbles inside. Shake it. Listen to them rattle. And here's the deal. An urn contains 3 black and 5 white marbles. A marble is drawn at random and replaced. Then a second marble is randomly drawn. What is the probability that both marbles are black? Okay, so this is part A. So, what's the probability that we reach in and draw a black marble, blacks and 5 whites? That would be 3 out of 8, right? And we put it back, and then we draw again, so that would be 3/8. So the probability of getting a black twice would be 9/64, right? And that equals the probability of both black with replacement, we say, because we put the first one back. Okay? Now, part B says, if the first marble is not replaced before the second marble is drawn, what is the probability that both marbles are black? Okay, so the first time we dip in, we're still looking at 3 blacks out of a total of 8 marbles, 3 plus 5. But this time we take our black marble and we set it down the hall. I don't know. Now, what's the probability of drawing another black in the urn? And there are still 5 white, but our total has... Does That makes sense? Because we didn't replace that first marble that we drew. We're assuming it's black because that's what we were trying to do. So now we only have 2 left to choose from. So the probability, and that reduces, this is the probability of drawing both black, but this is without replacement. That's what my abbreviation. This is with replacement, this is without replacement. So, the moral of the story is, if you take the marble that you drew the first time and throw it down the hall, then the probability of drawing that color again decreases. So don't throw marbles down the hall, boys and girls. All right, there's one more problem in this example in this lesson. An urn contains 4 red and 7 blue marbles. Shake them, hear them rattle? I can. 2 marbles are drawn at random. What is the probability that the first is red and the second is blue? Okay, so the probability of red then blue. And there are 2 ways. A is with replacement, and B is without replacement. Okay, so what's the probability of drawing a red? That would be 4 out of 11. All right, now we put it back in, and now we want to know what are the odds of drawing a blue. Well, there are 7 blue marbles, and we put the first red one back in, so it's 11 again. We still have the 4 in there. So this becomes 28 over 121. And that does not reduce. All right? Now, what happens if we draw the red marble, 4 out of 11, but this time we throw the red marble down the hall. When we go to draw we still have 7 blue ones in the urn, but we threw one of the red ones down the hall. This changes to 3, so this changes to 10. So we can see the odds actually go up that we'll get a blue one the second time, because we threw the red one down the hall, so that means there are just fewer marbles in the urn, and the odds of us choosing a blue one get better if we throw it down the hall. Those are the 2 answers. Oh, this can be reduced. Let's see, this would be 14 over 55, yes. If you're getting these answers right and just forgetting to reduce, yay, that's a big part of the battle. Yes, get the right fraction, that means you're understanding the concept, and that means I'm extremely proud of you. This is not easy, you guys. We're doing hard work. Okay. I'm going to tell you right now, lesson 74 is scientific notation, so buckle your seatbelt, and I will see you soon for that.